In this video, I'll solve two problems from section 6.4 and 6.5 homework assignments for extra practice for your final exams. So this is the first problem. For a product, the demand curve is given as P equal 100 e to the minus 0.008 Q, and the supply curve is given as P equal 4 square root of Q plus 10, and this is valid for the Q between 0 and 500. So Q, we know that Q is a quantity and P is the price in dollars per unit. Now, the first question they ask you, at the price of $66, what quantity are consumers willing to buy, and as what quantity are producers are willing to supply, and will the market push the prices up or down? And route your answers to the nearest integers. Okay, we have the answer here, but how do we get to the answer? Okay, first thing is, anytime I'm talking about a consumer, I know that I have to apply the demand equation. Okay, we have to use the demand equation. So the demand equation is given here: P equal 100 e to the minus 0.008 Q, and I know that now the price is given as 66. So let me plug in 66 here, and we are looking for the number of the units, the quantity Q. So we go ahead and we solve for Q. So we divide both sides, 66 by 100, divide both sides by 100, and e to the minus 0.008 Q. And now we want to solve for Q. Because we have the base E, you have to take the ln on both sides, right? So ln of 66 divided by 100 equal ln e to the minus 0.008 Q. The reason I take the ln because ln and e, they cancel out. You get back ln 66 over 100 equal minus 0.008 Q. Now we are looking for Q, so we have to divide both sides by minus 0.008. So Q equal ln 66 over 100 divided by minus 0.008. Okay, let's try that. Okay, ln 66 over 100, and then we divide that by minus 0.008, and that gives me 52.93. We round it to the nearest integers, which is 52 units. And this is the correct answer. Okay, so that is the first part. The second one, producer are willing to supply how many units? Anytime we are talking about a producer, we know that we have to use the supply curve. Okay, supply curve is right here, plus 10, and again, the price is still 66, so I plug in 66 for that. And we need to solve for Q, so I subtract 10 on both sides. We have 56 equal 4 square root of Q. And now to solve for Q, I need to divide both sides by 4 to isolate the Q. And now to solve for Q, I need to square both sides, right, to take away the square root. So I get Q equal 56 over 4 square. So let me wrap my calculator and then see what I get here. 56 divided by 4 and then square. Give me 196. which is right here. Okay, so we have little number of units that the consumers are willing to buy, and we have a lot of units that the producer are supplying. So we have more items being produced than consumed. So that's why the markets will push the prices down, because otherwise we have a lot of the items that are not bought by the customers. So the price will have to go down. Okay, we have more extra item than the need of the consumers. Too expensive, so it has to go down. The next question, find the equilibrium price and quantity. Okay, so remember the equilibrium point occurs when the demand and supply they are equal. So now we just have to set two equations equal to each other. So the demand is 100, e to the minus 0.008, q equal to supply 4 square root of q plus 10. Okay, this is very difficult to solve, because we have the exponential equation here, and we have the square root. So how do I solve for it? How do I solve for that equation? Now, it's not easy to solve the equation by hand, and therefore they ask you to use a graphing calculator to answer the following questions. So the better way that we can solve this problem is we graph the two equations on the graphing calculator, and we find the point of the intersections. Okay, so first thing is I input the first equation, 100 e to the minus 0.008 x. In this case, we just use the x variable instead of q. Okay, and then 4 square root of q square root of x plus 10. And then because we know that we are running on the q from 0 to 500. The q in this case is the x axis. So make sure that we adjust the window from 0 to 500. Because this is a large number of quantity. And then for the y value, we go from minus 10, maybe up to 100. So that you can view the whole window, or you can see the graph, because this is the big domain and the range. So now let's graph them. If you graph them, you can see that they intersect each other at this point, and this is the equilibrium point. And now we just have to find second, calculate the intersections. And the first curve, I move to the left of the intersection. Hit enter. Now let's find the second point. I move to the right, so that the point we're looking is in the middle. And then we hit enter, so that it's guessing for us. This is the point of intersection. So the x, remember the x in this case is the q value. So the x in this case is the q, or 91. So we route it to the nearest integer is 91. Okay, 91, which is right here. So q equal 91. And how do I find p star? Well, we can use any of the two equations to find for p. Let's just use the first equation. To find p star, we plug in q star to the given equation. E to the minus 0.008 q, and q here is 91. So let's see what we get here. 100 e to the minus 0.008 and then 91. That gives me 48, which is right here. So 48 is the answer for P star. Alright, so we got the point of equilibrium, and now we are at the step to find the consumer and producer surplus. Consumer surplus. Okay, so consumer surplus. Consumer surplus. We got the equation from the lecture. It's equal to the integral from 0 to Q star. Consumer go with the demand curve. Okay, dq minus P star Q star. Take the integral from 0 to Q star. Q star, we got 91. The demand curve in terms of Q, the demand curve is this one in terms of Q. So 100 e to the minus 0.008 Q. Make sure it's in terms of Q, right? Because we are running on the dq, and then minus P star Q star. P star is 48 times 91. Okay, let's see what we get from the graphing calculator. So you need to have the graphing calculator to do this problem. So math 9 get me to the integral from 0 to 91, and then 100 e to the minus 0.008 x. Just use the variable x for Q. And then if we use x, we have to put dx and then hit the enter. Make sure you do a subtraction. 48 times 91. And that gives me $2,096, which is right here. Okay, $2,096. Round it to the nearest integer. So this tells us that the consumer gains this much money when they buy the goods as the equilibrium price instead of as the price that they would have been willing to pay. Okay, the last one is the producer surplus. Let's do it here. Producer surplus. We know that we have the equation for producer surplus is P star Q star minus the integral from 0 to Q star. The supply producer go with the supply curve dq. So P star Q star, we know that's 48 times 91 minus the integral from 0 to 91 for Q star. The supply curve is this one, 4 square root of Q plus 10. So 4 square root of Q plus 10. Make sure that we are using the Q terms because we have dq. Okay, we have dq at the end. So now let's try. Let's see what we get here. Okay, we have 48 multiply with 91. Subtract the integral. So math 9. Integral from 0 to 91. 4 square root of Q, that's ux, and then plus 10, and then close that, and then dx. Enter. So $1,143, which is correct here. Okay. So that is how we solve the problem, consumer and producer surplus here. First one. This is a long problem, and we need to use a graphing calculator. Okay, the next problem, 6.5. A person deposits money continuously into an account. So he or she deposits money continuously. So this is the flow of money, the income stream of payments. Okay, which pays 5% interest compounded continuously. So we know R is 5% or 0.05 at the rate of 1,000 per year. So this is the flow of money. The flow of money is S of T, 1,000 per year for 18 years. So we have 18 years, the big M is 18 from the formula. Now find the balance in the account at the end of 18 years. So at the end of 18 years, that means the future value after 18 years. And we know that the future value, we got the formula e to the r m, the integral 0 to m s of t e to the minus r t dt. This is the future value of the income stream of payment. So e to the 0.05, 18, 0, 18, s of t is 1,000, and e to the minus r 0.05 t dt. Okay, t here is a timing from 0 to 18, so we are running dt from 0 to 18. So this is the variable t. Okay, let's try that. We have the integral mat 9, 0 to 18, 1,000, and then e to the minus 0.05, t is this x variable, and dx. Make sure we multiply with the e to the 0.05 times 18, and that's give me 29,192.06, and we route it to 0.07. Right, we can route it 29,192.07. Okay, so they route it a little bit differently. Maybe they use 2 decimal places here. We use the whole thing. That's why we got a little bit 1 point off from them, but that's fine. Calculate the money of the amount of money actually deposited into the account. Okay, that's simple. We have 1,000 deposits for per year. We make 18 years, so 18 deposits. So 1,000, 18 year, that is 18,000. Right here. Calculates the interest earned during the 18 year. Okay, so actually we only in the whole 18 years we only make 18,000 deposits, but after all the interest earned, we got at the end this much. So the difference between them is the amount of the interest that you earn. Okay, so we take 29,192.07 minus 18,000. So let's do that here. 29,192.07 minus 18,000. That's give me 11192.07, which is this value. Alright, so we are good for this problem.